I'm going to show you how to do some factoring, and I'm going to show it with two different methods. So this first one is the method of just factoring out a common factor by thinking of it as the reverse of the distributive property. So each of these problems here are being asked to factor. So the first one is y equals 7x to the fourth plus 8x cubed. So we can see that they have a common factor of x cubed. So that's what I'm going to factor out. Oops, don't want that color. So we're going to factor out an x cubed. And if we think about it as the reverse of the distributive property, I want to know x cubed times what will give me 7x to the fourth plus x cubed times what will give me 8x cubed. So thinking about it that way, x cubed times 7x will give me 7x to the fourth, and x cubed times 8 will give me 8x cubed. So again, I'm going to check that real quick. So I'm going to distribute the x cubed. X cubed times 7x is 7x to the fourth, and then x cubed times 8 is going to be 8x cubed. Check. So that is my factorization right there. Similarly, problem number 2 is slightly different, 7x to the fourth plus x cubed. Again, we're going to take a look at, they have an x cubed in common. So again, I'm going to factor out that common factor of x cubed and ask myself, x cubed times what will give me 7x to the fourth, and then x cubed times what will give me x cubed. So x cubed times 7x will give me 7x to the fourth, and then x cubed times what will give me x cubed? Well, the only number that if I multiply it by something else, it doesn't change it, is 1. So again, I'm going to check my work, and I'm going to distribute the x cubed. So 7x to the fourth, and then x cubed times 1 is my x cubed. Okay. All right, so now let's change it up a little bit. It's essentially the same problem, except what I'm going to factor out changes slightly. So if I look at problem number 3, y equals 7 times the quantity x minus 2 to the fourth plus 8 times the quantity x minus 2 to the third, again, we have a common factor, right? An x minus 2 to the third this time instead of just an x. But it works exactly the same way. I'm going to factor out, oops, keep forgetting to change back to white there. All right, factor out the common factor. Oh, come on now. There we go. Factor out the common factor of x minus 2 cubed. And again, I'm going to ask the same question. If I think about this as the distributive property, x minus 2 cubed times what will give me 7x minus 2 to the fourth. So I need a 7 and another factor of x minus 2, just like I did over on the other part right over here, right? And where's my, there we go. Right, just like I did right over here, right? These are the same idea, right? X cubed times 7x will give me 7x to the fourth. X minus 2 cubed times what? 7x minus 2 will give me 7 times x minus 2 to the fourth. Right, and then similarly, x minus 2 cubed times what will give me 8x minus 2 cubed. So I just need an 8. And from there, we can go one step further, and we can sort of clean up, simplify what's inside the bigger set of parentheses. So I'm going to distribute the 7 to get 7x minus 14 plus 8 is equal to x minus 2 cubed times 7x. Negative 14 plus 8, or minus 14 plus 8, is negative 6. And so that would be in our factored form. All right, and again, similarly, we have 7 times x minus 2 to the fourth plus x minus 2 cubed. We have a common factor, same common factor. And so that's what I'm going to factor out, is that x minus 2 cubed. And thinking about it as the reverse of the distributive property, x minus 2 times what? So I need a 7 and another x minus 2 in order to get 7 times x minus 2 to the fourth. And then x minus 2 cubed times what will give me x minus 2 cubed? Well, the only number that works is 1. And again, I can go ahead and simplify what's inside the big set of parentheses, 7x minus 14 plus 1. And so we'll just make this x minus 2 cubed times 7x minus 13. And we're all done. Okay? All right, so that's one method to think of this as the reverse of the distributive property. There's one other strategy we can use, and that is the idea that if we multiply anything by the same thing in the numerator and denominator, that's equivalent to 1, right? So if I multiply by something that it's equivalent to 1, it's not going to change the value, okay? All right, so the first step is still the same here. We have to determine what we have in common. And we figure out the common factor is x cubed. So what I'm going to do here is a slightly different approach. Is I'm going to multiply by x cubed over x cubed, the common factor. So essentially I haven't changed that. X cubed over x cubed is equal to 1 as long as we stay away from x equals 0. So the next step is I'm going to take the denominator, and just the denominator here, and distribute that to each of these. So if I do that, I end up with essentially the same thing that I had before. Let me move this guy down here. Didn't give myself quite enough room. And now 7x to the 4th over x cubed, that reduces, simplifies to 7x plus 8x cubed over x cubed is 8. So if I do that, the same thing with y equals 7x to the 4th plus x cubed, same strategy, multiply by x cubed over x cubed, the common factor, and then just distribute the denominator. Then I leave the x cubed out front from the numerator, and then 7x to the 4th over x cubed plus x cubed over x cubed. Then we get x cubed out front, 7x to the 4th over x cubed is 7x, plus what's x cubed over x cubed? Well, that's 1. Okay? So I achieved the same answer, but just a slightly different approach. So let's try that with our little bit more complicated ones, where the factor isn't just an x, but an x minus 2, and do that same strategy. So I'm going to multiply by the common factor, not x plus 2, x minus 2 to the 3rd, and over x minus 2 to the 3rd times 7x minus 2 to the 4th plus 8 times x minus 2 cubed. And when I distribute the denominator, again, right, we're going to distribute to there and there, I end up with x minus 2 cubed from that numerator that's left. And then when I bring the other over, right, what happens there? I end up with x minus 2 cubed. So I have 7 times x minus 2 to the 4th over an x minus 2 cubed. So that simplifies to just a 7 times x minus 2, right? Those 3 will cancel with 3 up there. reduce with those. And then same thing here. We have 8 x minus 2 cubed over x minus 2 cubed is equivalent to 1, or that reduced fraction in simplest terms is just an 8. And then from there we can simplify just as we did before. So I'm going to skip that step so that we can tackle problem number 4, which was y equals 7 times x minus 2 to the 4th plus x minus 2 cubed, and use this strategy of multiplying by the common factor in the numerator and denominator, and then distributing the denominator. So we get x minus 2 cubed, and then 7 times x minus 2 to the 4th over x minus 2 cubed, plus x minus 2 cubed over x minus 2 cubed. And when we reduce our fractions, put them in simplest terms, we get 7 times x minus 2 plus x minus 2 cubed over x minus 2 cubed is equivalent to 1. And again, I'll leave the rest of that algebra up to you. It works the same as it did in the other problems. So that's 2 different strategies. You can pick and choose which you like. They both work, and go from there.